Alrighty, here we go. Introducing the trigonometric ratios. These things here are a little bit of a beast, and you'll see them again and again and again throughout the rest of high school. So let's try and get this right. Alright, so what we're going to do, we've looked at triangles so far, we've looked at Pythagoras, and Pythagoras said a squared plus b squared equals c squared. And we also know for a triangle that if you have three angles, that the three angles will add to 180 degrees. Trigonometry, in and of itself, is going to look at linking the sides and the angles. So there is actually a connection between the two. Okay, so what I can do, just to demonstrate this, if I draw you two right-angled triangles, this one here, that's a pretty bad drawing, but bear with me. That's 5, that's 4, and that's 3. And I draw a similar triangle, so the same thing but bigger. And if this is 10, that's 8, and that's 6 here, both right-angled triangles. So going from the 4 here to the 8, I've doubled it. The 5 to the 10, I've doubled it. The 3 to the 6, again I've doubled it. What would happen here is that this angle here, which I'll call theta, this fancy zero looking thing with a cross through it, the theta here, these angles will be the same on both of these triangles. And this is a property we apply, it's a similar triangle property, but we do abuse this a little bit when it does come to studying trigonometry. So our theta here is the same, doesn't matter how big our angles are, as long as our triangles are similar. So these here, similar, double, or half, depending on which way you go. Similarly, these angles up here, which I'll call alpha, like a funny looking A, they will be the same as well. So trigonometry, we're going to look at connecting these angles here with the side lengths of these triangles. Okay, so what we're going to say it's a ratio. Trigonometric ratios here, the whole idea is based on the idea of ratios like we would see in similar triangles. So what I'm going to do, I'm going to look at just connecting sides on triangles. If I do have a right-angled triangle here, and I call this theta, I've got three sides, 3, 4, and 5. And I'm going to draw up ratios between two of the different sides. Okay, so looking at theta here, well, before I actually can start defining ratios, start talking about ratios, I'm going to talk about side lengths, what the sides are, how to label our sides. Like we said, we're trying to connect angles here with sides, so we need to label the sides properly. Our first side you should know, opposite the right angle here, from our work in Pythagoras, this side here, this 5 will be the hypotenuse. And the hypotenuse is still a hypotenuse here, doesn't make any difference. Okay, the right angle, opposite the right angle is the hypotenuse. Next, we need to know where our unknown angle is. So our angle here, theta. And our last two sides get defined in terms of theta here. If that's theta here, opposite theta on my example is 4. Opposite theta, 4 here, we call this side the opposite. Okay, opposite the angle. This one here, this 3, is next to the angle, and we use the word adjacent for that. So that's the adjacent there. Adjacent being just a fancy maths word for saying next to. Next to. Okay, so the adjacent angle there, the opposite, and the hypotenuse. So if any triangle we have, this is theta in here, labeling our sides, we have this side here, it's going to be the hypotenuse. Opposite the angle, that's my angle there, opposite's going to be over here. And our last side is next to the angle, we call that the adjacent. And as a practice, normally label the hypotenuse first. It does save you getting confused with the other sides. So we'll do one or two more examples of that. I'm just grabbing another triangle here. Okay, right angled, we'll put our angle in there. Labeling sides, right angle here, this would be my hypotenuse. Opposite my angle's here, opposite the angle's over here, that's opposite. And next to my angle, well, that's already been taken, that's been taken. This here will just be the adjacent. So my opposite, my hypotenuse, and my adjacent. And one last example. So you should be pretty well guessing for yourself the labels at this stage. If theta is here, my sides I have right angle here, it's the hypotenuse, HYP for hypotenuse, theta is there, this would be my opposite, I'll just OPP, opposite, and next to it will be my adjacent. Okay, so hypotenuse, opposite, adjacent, you need to nail your labeling. If you get your labeling wrong, you're going to be in all sorts of trouble later on. From here, we have the trigonometric ratios. So what I'm going to do, if I draw up a triangle, there are 3 ratios we really want to consider. So I'll put my theta in here, label my sides, hypotenuse, opposite, and adjacent. My first ratio all has to do with theta here. So theta, my first ratio is going to be my opposite over my hypotenuse. It's opposite over hypotenuse. And that ratio, opposite over hypotenuse, we call the sine ratio. So sine theta equals opposite over hypotenuse. My next ratio, I'm going to have the adjacent over the hypotenuse. And adjacent over hypotenuse we call the cosine ratio, or just cos. And our last ratio is going to be the opposite over the adjacent. And that is my tan ratio. So tan theta equals opposite over adjacent. These 3 ratios you need to know. These 3 here should be memorized. In terms of trying to shortcut a little bit just about memorizing these, we will refer to a thing, I suppose, a figure of speech of SOHCAHTOA. So if we have SOHCAHTOA, SOHCAHTOA, each of these break down to 3s here. SOH has to do with sine, CAH has to do with cos, TOA has to do with tan. S comes from sine here, S for sine, and sine is opposite over hypotenuse. So sine, opposite over hypotenuse, SO. Okay, just a nice way of memorizing these. Cos is next. Cos is adjacent over hypotenuse, so cos adjacent over hypotenuse. TOA, tan, is opposite over adjacent. Do very well to memorize these. Application of this, I suppose, is really important. So if we pull out the example that we had before, if I have my 2 triangles, I'll just draw them up here a little bit smaller. So if we have theta here, we had 4, 3, and 5, and we had theta here, and we had 10, 8, and 6. Okay, they are similar triangles. Again, the scale factor would be 2. Looking at these, if I pull sine out, sine's opposite over hypotenuse, sine opposite over hypotenuse. So opposite is 4 on 5. So for this example here, sine theta would be 4 on 5. And the big triangle, sine theta, would be 8 on 10. Opposite is 8 here, 10 there, 8 on 10. Cos theta, would be the adjacent over the hypotenuse, adjacent over hypotenuse from cos. So my adjacent here is 3, my hypotenuse is 5, so 3 on 5. And in my bigger triangle here, 6 on 10. Okay, and you will note that 8 on 10, 4 on 5, 8 on 10 simplifies to 4 on 5. 6 on 10 here simplifies to 3 on 5 as well. So it's the same value. I would expect that because the triangles are similar. Lastly, tan. Tan is going to be opposite over adjacent. So opposite's 4 here, adjacent's 5. Sorry, no, it's not. Opposite's 4. Hope if I labeled it opposite, hypotenuse, and adjacent. Opposite over adjacent, TOA, tan, opposite on adjacent. Opposite's 4, adjacent's 3. On my bigger triangle, opposite is 8 here, adjacent is 6. Opposite on adjacent is 8 on 6. And of course, 8 on 6, 4 on 3 are the same thing, just simplified. So simplify 8 on 6 will get you 4 on 3. So here, it's the same ratio based on using SOHCAHTOA. Okay. To give you another question, another example, if I gave you this triangle here, and I ask you to find the values of sine theta, cos theta, and tan theta. So if I have 5, 12, and 13 here, and theta can be here, I'm linking my angle now with 2 sides. So if I said find sine theta, cos theta, and tan theta, so sine theta, well, from my SOHCAHTOA, I will write that out pretty much every time I have a trig question. So, ka, and toa here. So firstly, sine. Sine's opposite over hypotenuse. So if theta is there, my hypotenuse is going to be 13. My opposite is 12, and my adjacent is 5. So sine theta, opposite over hypotenuse is 12 on 13. Cos theta is adjacent over hypotenuse, so adjacent is 5, hypotenuse is 13. Tan theta, opposite over adjacent, TOA, opposite over adjacent, opposite's 12 on 5. Always revert back to SOHCAHTOA, help me get those values. It's important to note here what we are doing in any one of these ratios. So take sine here, for example. We're taking an angle and we're linking it to 2 sides. So sine theta, theta is the angle, opposite hypotenuse, that's 2 sides. Down at cos here, got theta here, so my angle, linking it to 2 sides, 5 and 13, my adjacent, my hypotenuse, 2 sides and an angle. Tan here, theta, 12 and 5, again 2 sides and an angle. Pythagoras linked 3 sides. So Pythagoras 3 sides, 3 angles was angle sum, but trigonometry we're looking at linking here 1 angle and 2 sides. So always 1 angle, 2 sides. If you're thinking 1 angle, 2 sides, you're looking at a trigonometry question. Okay. Taking something like this now, if I have this being, say, 9 and this being 15, so here if I've got this, what ratio is it going to be if I'm trying to link this using trigonometry? Well, I'm looking at linking a side here, and an angle. So 2 sides and an angle. I'm looking at trigonometry. Okay, no side here, we're not interested in that side. If we had that side there, it would be a Pythagoras question. That would be 3 sides. But we're looking at 2 sides and an angle. So 2 sides and an angle, trig, trig, SOHCAHTOA. Toa. Okay, so sine, cos, and tan. Sine, cosine, tan, or tangent, more formally known. What we've got here, we need to work out what we're dealing with. So if theta is in here, labeling our sides, this 15 here, that is going to be my hypotenuse, just like Pythagoras. Okay, hypotenuse, opposite the right angle. Opposite the right angle, hypotenuse. Theta here, opposite theta is going to be the opposite. So this here would be the opposite. And adjacent, our fancy word for next to, adjacent down here. Okay. Note the adjacent here is not the hypotenuse is already labeled. So what I've got here, I've got an adjacent, I've got a hypotenuse, so I'm looking for adjacent and hypotenuse in my ratio. So, sine, I've got opposite and hypotenuse. I don't have the opposite here, so I don't have that, I'm not going to use that. Also here, tan, opposite, I don't have that. What I do have, I have my adjacent, I have my hypotenuse. My adjacent being 9, my hypotenuse being 15. This is going to be a cos ratio. And I can say that cos theta equals adjacent over hypotenuse, so it's 9 over 15. So cos theta here is 9 on 15, linking my sides here with my angles. Taking another example. If I have my theta in here, and I've got, say, this side here being 6, this side here being 12. Looking at linking two sides here and an angle, two sides at an angle, trigonometry, SOHCAHTOA. Okay, remember, 3 sides is Pythagoras, 3 angles, angle sum, 2 sides at an angle, 2 sides at an angle is going to be a right angled triangle is going to be trigonometry. So 2 sides, my angle in here. What sides have I got? That's my right angle. This is my hypotenuse. I don't have my hypotenuse. I'm not interested in my hypotenuse. There's no x here. There's no numbers here. So hypotenuse, don't really need. Sines out, cos out. It's going to be tan. Okay. Just finishing off my labeling. If this is theta in here, I've got my opposite here, and my adjacent, my next to one, is my 12 here. Fancy adjacent, my word for next to. So I'm saying here tan of the angle, tan of theta, all in terms of the angle. Tan of theta is going to be opposite over adjacent, TOA. Opposite over adjacent is 6 on 12. Okay. And I'll use that property later. You'll see linking this all a bit more in future exercises. What's really important that you guys are getting today is that sine theta, cos theta, and tan theta, these definitions here. If you get those down from here, make sure you're labeling in your triangles what's opposite, adjacent, and hypotenuse, and substituting in using SOHCAHTOA. Okay. In general, we will be linking them like we've seen in our last 2 questions, but for now, make sure you've got SOHCAHTOA, make sure you're labeling correctly, make sure you're substituting in correctly as well. Okay. Our ratios, sine theta, sine opposite over hypotenuse, sine opposite on hypotenuse, cos adjacent on hypotenuse, ka, tan opposite on adjacent. Okay. Get some practice on those, and thanks for watching.